Hello everybody, welcome into another lesson. So today we are going to talk about arithmetic series. So in the last lesson we talked about arithmetic sequence. Now we're going to talk about an arithmetic series. Well, if we recall from yesterday when we talked about introduction to series, whenever you have a series, you have to start out by trying to find the formula for the nth term of the sequence. So you're going to treat this like a sequence at first. Here we have the sum of 3 plus 8 plus 13 plus 18 plus 23, and it just keeps on going and going. I should probably make that a plus dot 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 to indicate that it keeps going. But we see here this is definitely an arithmetic series because the common difference is 5. So let's establish that the common difference is 5. Now, we can go ahead and find a term for the sequence. That would be a sub n equals your first term of 3 plus that quantity of n minus 1 times the common difference of 5, which would simplify into 3 plus 5n minus 5, so a sub n equals 5n minus 2. So we have the term now for the sequence. Now we need to put this into a series. And for this series, in this case, we want to find the sum of the first 20 terms. So n will equal 20. If we remember for the sum, so the sum of n, that would be your sigma notation for the sum. It's going to start with, again, I equals 1. Now you want to find the sum of the first 20 terms. That's going to be your upper index of your upper limit of summation would be 20 then, since you're trying to find the sum of the first 20 terms. Then you would just put in your formula for the sequence. So this would be 5i minus 2. Alright, now, you could write out the first 20 terms and add them all together, which would be a real pain in the neck, especially if you're ever asked to find like the sum of the first 200 terms or something. Are you going to want to sit out and write 200 terms and then add them all together? I don't think so. The formula for finding the sum of an arithmetic sequence is always the number of terms you're seeking to add, that n, times your a sub 1 plus your a sub n divided by 2. That's how you find the sum of an arithmetic sequence. So it's going to be the number of terms you're seeking to find the sum for times the quantity of the average of your first term and the number of the term you're seeking. So let's find this here. So in this case, we're going to try to take 20 terms. So the sum would be equal to 20 times our ace of 1, which is 3. 3 is our first term, plus we need to find a sub 20. So we can do that if we put it into our sequence formula, right? So that's going to equal 5 times 20 minus 2, which would give you 100 minus 2, which would then of course give you 98. So your 20th term is 98. So this would be 3 plus 98 divided by 2. Okay? Now, let's do the work in the parentheses. You'll get 20 times 101 divided by 2, which would simplify into 10 times 101, which would give you 1010. So the sum of this particular series of the first 20 terms would end up being 1010. And I got more where that came from, but there's also a second part to this. We're also going to be asked to find something else here. we are going to be asked to find, we're going to write the term in general as n as our upper limit of summation. We need to find the number of the term where the sum equals 366. So you may be asked also to find what term number gives you a sum of 366. So how would you do that? Well, again, here's your sum formula, right? So plug this in here. You'll have 366 as your sum is equal to n, which we just don't know what that is, times the quantity of your a sub 1, which is 3, plus the a sub n. Well, a sub n is 5n minus 2, right? You'll just plug that in, divide all that by 2. So this would become 366 equals n times the quantity of 5n plus 1 divided by 2. Which then means that n times 5n plus 1 is equal to 732. Well, we're going to end up having a quadratic equation. We'll end up having 5n squared plus n minus 732 is equal to 0. Yeah, that wasn't very pretty, but that's exactly what we got here. Alright, so let's go ahead and see what we can do here. Let's see if this will factor at all, which I don't get warm fuzzy feelings about it, but let's try it. Let's see what we can factor. Well, looks like we're going to be getting into the quadratic formula. So let's do that here. So let's see, n would equal the negative of that b term, so that'd be negative 1 plus and minus the square root of 1 minus 4 times 5 times negative 732 all over 2 times 5, which is 10. So that's going to equal negative 1 plus and minus the square root of 1 plus, let's see what this is all about. $14,640 so this would equal negative 1 plus and minus the square root of 14,641 all over 10, which, let's find the square root of 14,641. Alright, so the square root of that is going to be 121. So you'll get negative 1 plus and minus the square, which would be actually just 121, all over 10. Well, when you find term numbers, you can't have a negative term, so you're only going to consider the positive. So if you take negative 1 plus 121, you're going to get 120 divided by 10, which would be 12. So that means in this case, the sum of the first 12 terms would have a sum of 366. That's how you would go about finding that. And I got more examples here. All right, what's the next one? 50 plus 42 plus 34 plus 26 plus 18 plus dot dot dot. It continues on and on. So we have 50 plus 42 plus 34 plus 26 plus 18 dot dot dot. It continues on and on. Arithmetic series, the common difference in this case is -8 because it goes down by 8 between each term. So you have a difference of -8. So let's go ahead and find the formula for the sequence part of this. So a sub n would equal your first term of 50 plus that n minus 1 times -8. So this would simplify into 50 minus 8n plus 8, which means the formula for the sequence is going to end up being 58 minus 8n. So that's the formula for the sequence. Now, we're being asked to find the sum of the first 40 terms. So n will be 40. So we need to convert this to a sum. So the sum is going to equal, in this case, again, your I will equal 1. That's where your sum starts. We're trying to find the sum of the first 40 terms, so 40 will be your upper limit of summation. And then just plug in your sequence formula of 58 minus 8n. So there's your sum. Now, to find said sum of the arithmetic sequence, again, it's the number of terms, so this case 40 times the quantity of your a sub 1, which is 50, plus your a sub n, which would be a sub 40. Well, let's find a sub 40. That, of course, would equal 58 minus 8 times 40, which would give you 58 minus 320, which, now let's just do 58 minus 320. That would give you negative 262. So the 40th term is going to be negative 262, so this will be 40 times the quantity of 50. This will turn into minus 262 divided by 2, which then would give you 40 times, now let's figure out what 50 minus 262 is. That'd be negative 212 divided by 2. So then you would end up taking, of course, 40 times, this simplifies into negative 106. So now let's take, let's see, so 40 times negative 106 is negative 4,420. So the sum of the first 40 terms would be negative 4,240. That's exactly what you would get for the sum of the first 40 terms. All right, now, what if, in this case, there's a second part to this problem. We need to find the term number where the sum equals 182. So we're going to find what term number will give us a sum of 182. So plug in your formula again. 182 equals n times the quantity of your a sub 1, which is 50, plus your a sub n, which is 58, minus 8n. Go ahead, divide all that by 2. Well, this means 182 would equal n times 108 minus 8n divided by 2. So 182 would equal n now times this quantity here, both terms of the numerator divide by 2, so this would become 54 minus 4n. So 182 equals n times 54 minus 4n. So 182 equals 54n minus 4n squared. So 4n squared minus 54n equals 182. Or actually, minus 182, excuse me. Minus 182, or plus 182 rather, is what I meant to say, equals 0. So 4n squared minus 54n plus 182 equals 0. Let's see if we can't factor this any. I know we can factor out a common 2, so this would turn into 2n squared minus 27n plus 91 equals 0. And really, that's about the best we can do. So guess what? Quadratic formula time. So n equals the negative of b, so negative 27 would be positive 27 plus and minus the square root of your b squared, so that would be that negative 27 squared minus 4 times your a of 2 times your c of 91 all over 2 times your a of 2, that'd be all over 4. So let's figure out what the heck is underneath the radicand, what all this means. So let's figure out what 27 squared is. That's 729 minus 4 times 2 times 91. So that's really 8 times 91. That'd be 728. Divided by 4. So what you'll get then is going to be 27 plus and minus the square root of 1 over 4, which would give you 27 plus and minus 1 divided by 4. But here's the thing. If we do 27 minus 1, you'll have 26 over 4, which would give you 13 halves, or the 6½ term. For finding a term, you can only have integers. So that means we have to do 27 plus 1, which would end up giving you 28 over 4, which means n equals 7. So the sum of the first 7 terms would equal 182. So we can't have the sum of the first 6½ terms. That just doesn't work. It's going to be the sum of the first 7 terms. All right, I got 4 more. we have negative 10 plus negative 5 plus 0 plus 5 plus 10 plus dot dot dot. All right. So the series here is negative 10 plus negative 5 plus 0 plus 5 plus 10 plus it just continues infinitely. So what is the common difference between each of these terms? It's 5, right? So the common difference is going to be 5. Now let's go ahead and find a formula for the nth term of the sequence. So a sub n would equal, well, a sub 1 is negative 10 plus the quantity of n minus 1 times that common difference of 5. So that's going to give you negative 10 plus 5n minus 5. So that means the formula for the nth term of the sequence is going to be 5n minus 15. So that is now the formula for the nth term of the sequence, or the sequence formula in general. Now this time they want us to find the sum of the first 19 terms. So we got to find the sum of the first 19 terms. So we got to convert this to sigma notation. So the sum is going to equal, let's get out our sigma symbol. Again, I equals 1. That's where it starts on the first term. We're going to find it for 19 terms, so we'll place the 19 above the sigma sign. That's our upper limit of summation. And now put in your sequence formula. This would be 5i minus 15. So we got the sigma notation for the sum of the formula. Now, for the sum of this arithmetic series. Now, let's break this down. So there are 19 terms, so the sum would be 19 times the quantity of your a sub 1, which is negative 10, plus your a sub n, so we got to find a sub 19. So let's go ahead and find that. That's going to end up being 5 times 19 minus 15, which would actually then end up giving you 95 minus 15. I don't know where I'm getting a denominator from. I'm thinking of the next step. So 95 minus 15 is 80. So your 19th term is 80. So this will be negative 10 plus 80, all that divided by 2. So this would give you 19 times 70 divided by 2, which would give you 19 times 35. Now we just got to take 19 times 35, and we have the sum of the first 19 terms of the series. Which would give you 665. So the sum of the first 19 terms of the series is going to be 665. Now, we found the sum of the first 19 terms. Here's the second part of the problem. We need to find the nth term when the sum of the series equals 375. So we're going to go ahead and find the nth term, the upper limit of summation, if you will. That would give us a sum of the series being 375. So 375 would equal n times the quantity of your a sub 1, which is negative 10, plus the a sub n, which is going to be 5n minus 15, all that divided by 2. So that means 375 would equal n times the quantity of 5n minus 25, all over 2. So that would end up meaning that 750 equals n times 5n minus 25. So you'd end up getting that 5n squared minus 25n minus 750 is equal to 0. And we can definitely divide everything by 5, right? You would end up getting n squared minus 5n. That should be 150 if I'm not mistaken. If you divide 750 by 5. Yep, 150. So you're going to have n squared minus 5n minus 150 equals 0. And I'm pretty sure there's not going to be anything that... Well, wait a second. What about 15 and 10? I think we can factor this. So if I take n with 10 and n with 15... Let's see if we can factor that. So n squared minus 15n plus 10n, so that would be minus 5n minus 150. Okay. So quantity of n plus 10 times the quantity of n minus 15 equals 0. You get n equals negative 10, and then n equals positive 15. Well, again, you can't have a negative 10th term. You're not going to have a negative term of a sequence. That doesn't work. So the only solution is the positive solution. That means the term you seek is the 15th term. So the sum of the first 15 terms equals 375. I got 3 more. All right. We have 34 plus 31 plus 28 plus 25 plus 22 plus ... So again, this arithmetic series continues infinitely. So it looks like the common difference is negative 3. We actually drop 3 from each term. So the common difference is negative 3. Now let's find a formula for the nth term of the sequence. So a sub n would equal your a sub 1, which is 34, plus the quantity of n minus 1 times negative 3, which would simplify into 34 minus 3n plus 3, which means the formula for the nth term of the sequence would be 37 minus 3n. So there is the formula for the nth term of the sequence, 37 minus 3n. Now, we need to find the sum of the first 32 terms. So we're going to find the sum of the first 32 terms. So the sum of the 32 terms, that's going to, of course, be your sigma, where your I equals 1, your first term. You're finding it for 32 terms, so 32 is your upper limit of summation for the formula of 37 minus 3i. So that would be the sigma notation for this. Now, we need to then use our arithmetic series formula to find the sum of the first 32 terms. So 32 for your n times the quantity of a sub 1, which is 34, plus your a sub n, which would be a sub 32 in this case. So we need to find the 32nd term. So that would equal 37 minus 3 times 32, which would give you 37 minus 96, which once we find that answer, we'll have our 32nd term. So take 37 minus 96, you get negative 59. So the 32nd term is negative 59, so this will actually turn into 34 minus 59, all that all over 2. All right, so this will become 32 times, now we got 34 minus 59. Let's simplify that a bit. That'd be negative 25 all over 2. Well, the 2 will cancel into 32. You'll get 16 times negative 25, which would give you a sum of negative 400. So the sum of the first 32 terms of the series is going to be negative 400. Now here's part 2 to this problem. We need to find, when the sum of the series, what term, the sum of which term numbers would equal negative 12. So the sum to what term would equal negative 12? Okay, so we'll put in negative 12 for our sum. That's going to equal n, because we don't know that, times the quantity of a sub 1, which is 34, plus a sub n, which is going to be 37 minus 3n divided by 2. So that means negative 12 equals n times 71 minus 3n all over 2, which means that negative 24 equals n times 71 minus 3n. So this would become negative 24 equals 71n minus 3n squared. So we'll end up having 3n squared minus 71n minus 24 is equal to 0. Now, let's see if we can factor. I'm not 100% sure that we can, but let's see here. Alright, so if we take, I think we can actually. So if we take n and then we have a 3n, then you use 24 and 1. So 3n squared plus n minus 72n. Yep, that'll give you negative 71n minus 24 equals 0. And then, of course, you would get that n equals 24 as well as negative 1/3. Here's the thing, you can't have the negative 1/3 term. That doesn't work. So the answer you're looking for is going to be n equals 24. So it's the sum of the first 24 terms that equal negative 12. And I got 2 more, then we're done. Alright, so we have 2 plus 9 plus 16 plus 23 plus 30 plus ... So we have another arithmetic series here. 2 plus 9 plus 16 plus 23 plus 30 plus ... It keeps going and going. So common difference between all the terms is 7. So the common difference is 7. Let's find a formula for the nth term of the sequence. So that'd be a sub n equals your a sub 1, which is 2, plus the quantity of n minus 1 times that common difference of 7. So you would get 2 plus 7n minus 7, which means the formula for the nth term of the sequence is going to be 7n minus 5. So that's the formula for the nth term of the sequence. A sub n equals 7n minus 5. Now let's see, they want us to find the sum of, the first 68 terms. They want us to find the sum of the first 68 terms. So let's convert this to sum notation. Sum of s sub 68. Well, that's going to be your sigma notation from I equals 1. You're starting on the first term. They want you to find the first 68 terms, so 68 will be your upper limit of summation. And then put in your sequence formula. That would be 7i minus 5. So what does that look like? That's going to be n, which is 68, times the quantity of a sub 1, which is 2, plus your a sub 68. So let's find a sub 68. Well, that's going to equal 7 times 68 minus 5. So let's figure out what the heck 7 times 68 is. That's 476, so that would be 476 minus 5. So your 68th term would be 471. So this would be 2 plus 471 divided by 2. So this will become 68 times 473 all over 2, which would turn into 34 times 473. So let's find 34 times 473. That's going to be a fun number. That'd be 16,082. So this means the sum of the first 68 terms of the series is 16,082. Now there's a second part to this problem. They want us to find when the sum of the series equals 1,661. So we got to find how many terms it takes to add together to get the sum of 1,661. So take your sum, the 1,661, set it equal to n, times the quantity of a sub 1, which is 2, plus your a sub n, which is 7n minus 5, all that divided by 2. So that means 1661 equals n times the quantity of 7n minus 3 all over 2, which means we can simplify a little bit more here. 1661 times 2, so that means 3,322 is equal to n times 7n minus 3. So this means that 7n squared minus 3n minus 3,322 is equal to 0. And to be honest with you, I think the best we can do is the quadratic formula. We're going to have to do that, unfortunately. So n would equal the negative of b, which would be negative 3, so positive 3 plus and minus the square root of your b squared, that negative 3 squared, minus 4 times your a of 7 times your c of negative 3,322 all over 2 times your a of 7, that'd be all over 14. So you'll get 3 plus and minus the square root of 9. And then let's find negative 4 times 7 times negative 3,322. We know that's going to be positive 93,016. All over 14. So that was a big number. So that's going to equal 3 plus and minus the square root of 93,025 all over 14. So let's figure out what the square root of 93,025 is. Well, that's going to end up being 305. So that would give you 3 plus and minus 305 all over 14. Well, here's the thing. If we did the minus, you would get negative 302 over 14. Well, you can't have a negative term number. So you're going to have to take 3 plus 305 over 14. That means n equals 308 over 14. So the term we seek, once we find 308 divided by 14, we have the number of terms we need. 22. So that means the n is 22, so the sum of the first 22 terms equals 1,661. And I got one more, then we're done. Alright, so we have 2 plus 16 plus 30 plus 44 plus 58 plus ... So 2 plus 16 plus 30 plus 44 plus 58 plus ... So this is another arithmetic series that continues on infinitely. Well, we can establish that the common difference is 14. There's a difference of 14 between each term. It goes up by 14, so your common difference is 14. Now let's find a formula for the nth term of the sequence. So a sub n equals your a sub 1, which is 2, plus the quantity of n minus 1 times your common difference of 14, which would simplify into 2 plus 14n minus 14, which means the formula for the nth term of the sequence would equal 14n minus 12. So now we found the formula for the nth term of the sequence being 14n minus 12. Now, they want us to find the sum of the first 24 terms. So we need to find the sum of the first 24 terms. So the sum of the first 24 terms, s sub 24, is going to equal the sigma notation from I equals 1, your first term, to 24, which is your upper limit of summation, since we're doing 24 terms. Then put in 14i minus 12 for the formula for the summation. Now, what is this really going to equal? Well, we're doing 24 terms, so n will be 24 times the quantity of a sub 1, which is 2, plus a sub 24, which we actually need to find. So that's going to be equal to 14 times 24 minus 12. So this will be a fun one here. So that would be 336 minus 12, which then would equal 324. So your 24th term equals 324. So 2 plus 324, all that divided by 2. Okay, so this will turn into 24 times 326 divided by 2, which would give you 24 times whatever 326 divided by 2 is. I would think 163, but let me be sure. Yep, it is 163. So it's just 24 times 163. Let's figure out what the heck that is. 3,912. So the sum of the first 24 terms of this series are equal to 3,912. And there's one more part to the problem. We need to find the sum of how many terms equals 2,178. So we're going to find the sum of how many terms equals 2,178. Okay, so the sum is 2,178. That equals n, which we don't know yet, times the quantity of a sub 1, which is 2, plus your a sub n, which is 14n minus 12, all that divided by 2. So 2,178 equals n times the quantity of 14n minus 10 all over 2. Well, both terms of the numerator of this quantity both divide evenly by 2. So this means 2,178 equals n times the quantity of 7n minus 5. So this would turn into 7n squared minus 5n minus 2,178 equals 0. And I'm thinking that the quadratic formula is probably our best option at this point. So n would equal the negative of b, so negative 5, that's positive 5, plus and minus the square root of your b squared, so that's negative 5 squared, minus 4 times your a of 7 times your c of negative 2,178, all over 2 times your a of 7, which would be 14. So this is going to equal 5 plus and minus the square root of 25. No, negative times negative will become a positive. So let's figure out 4 times 7 times 2,178. So 4 times 7 times 2,178 is equal to 60,984. Or am I getting dyslexic? Let me make sure I read that right. 60,984, I was right. All over 14, which is going to equal 5 plus and minus the square root of 61,000 and 9. So this would be the square root of 61,009 then, all that all over 14. So let's figure out what the heck the square root of 61,009 is. That would be 247. So we have 5 plus and minus 247 over 14. Well, if we did minus, that would give you a negative term, which you can't have a negative term. So you got to do 5 plus 247 over 14, which would actually give you 252 divided by 14. So once we got that, we have the term number that we need. So let's take 252 divided by 14. That's going to be 18. So the n equals 18, meaning that the sum of the first 18 terms of this series equals 2,178. All right, so that's it for Arithmetic Series. The next lesson we will introduce geometric sequences. So we'll do geometric sequences in the next lesson. So I hope everyone has a great night. Take care.